Hello viewers, welcome to my channel. Today we shall be looking at a very crucial topic for the senior secondary category in mathematics and further mathematics, and that is gradient of a straight line. Gradient has to do with the increase or decrease in the magnitude of something. In this case, we'll be associating it with straight lines. These straight lines in question could be the road that you walk on, or the pathway to your marketplace, the pathway to your farm, as the case may be. All right, so another term that we can use in place of gradient is slope. And when we mention slope, then what comes to mind is something like hill or mountain. So, how hilly can we say a particular surface is? And that is when we bring the concept of slope. All right, so this is the mathematical representation or the formula for calculating the gradient of a straight line. That is dy dx, change in y all over change in x, which we translate to mean y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. All right, so here are some of the various kinds of gradients that we have. The first of its kind here is the positive gradient. When can we say we have a positive gradient? When you have a graph where the line slants in this form. As long as the line slants in this form, then what you are dealing with is the positive gradient. From there, you should be able to pick 2 points along the line. Say, for example, at this point and this point. Then we have chosen a point along this straight line. And to calculate the gradient, all you need to do is to construct a right angled triangle out of that line after choosing 2 locations there. All right, so to now go further to do that, the highest point of the triangle formed is known as the y2. That's the highest value of y there. Then the lower point of the triangle, that's the right angle triangle, is known as y1. Any reading you are having along y here represent y1. The reading you are having along y here is the y2. That's the highest point of y. Then the region or the particular point where the right angle is formed is known as x2. That is the highest point of the triangle formed. All right, so the lower part of it, which is not the place where the right angle is formed, is the x1. Whatever value that is being read here in the form of x is your x2. The value that is reading here is your x1. And whenever you have something of this nature, you are going to have the positive value of your slope or gradient, which I denote with plus m, where m represents the slope. Because in every equation of line, the equation must be of the form y is equal to mx plus c, where the m here represents the gradient or the slope of that particular line, and the c represents the intercept on the y-axis. Here we have another type of gradient. Immediately after this, I will be showing you some few examples on how to calculate this. This particular topic will equally help you in physics practicals when it comes to plotting of graphs and finding the slope or the gradient of that particular concept that one may be looking for. All right, so negative gradient, you can see the line slant in this form whereby you are moving up the hill. It's just like somebody climbing up the hill. But this particular one, you see that the lines slant in such a way that one is coming down the hill. So it's going to be the form of deceleration. In physics, they call it acceleration when it goes up in this form, then deceleration when it goes down in that form. And when it goes down, the value of your acceleration becomes negative. And that's why you call it deceleration. All right, so whenever you plot a graph, y-axis, x-axis, and you plot a graph in such a way that you have your line in this form, what you have in that case is a negative gradient or slope, as the case may be, where the upper point of the triangle represent the y2, then the lower part of the triangle located towards y-axis represent your y1. Then the place where the right angle is formed represents the x2 as we have it here. But this time around, that will now be the aspect that will bring about the negative aspect of the graph because everything is going down. So you are counting backward. All right, so this one becomes x2, then the lower point of your x becomes x1 in this case. You find out that the value that you have here will be bigger than the value that you have here because after the origin, you'll be counting -1, -2, -3 going this way. And you know that if, for example, this place is -1 and this place is -4, -1 is bigger than -4. So therefore, when you now say x2 minus x1 is going to give us a negative value on the down part of what? On the down part of the equation, as you can see here, that is change of x. All right, so that is exactly how to go about the negative gradient. So once you have this line, you should look forward to having a negative answer to your slope. So we can say that our slope is negative. That's m is negative. Now coming to the third type of gradient here, that is the one we call zero gradient. When do you have a zero gradient? You only have a zero gradient when you have in a graph, as you can see, this y-axis, this x-axis, and you plot your graph in such a way that the line that you've plotted is parallel to x-axis. Pay attention to this. When the line is parallel to your x-axis, then you have a zero gradient. I'll be showing you some examples on how to go about calculations of this using graph. Then on the other hand, undefined gradient. In the undefined gradient, or the one they may call infinity gradient, when y-axis is parallel to the line, or the line that you have plotted is parallel to y-axis, then you have undefined gradient. So your gradient in this case is undefined. Is undefined. And this particular example is zero in this instance because if you have a value here, let's say 2, and your x is 0, what does that represent? It represents infinity or undefined value. If you punch this in your calculator, you're going to see math error or can't divide. That is to tell you that it is what? An undefined gradient. So in such example, you are going to be having a value up here and 0 on the denominator represent the difference between x2 and x1, because as you can see from here, the value of x will remain the same for x2 and x1, but the value of y can vary because you can locate the value of your y2 here and y1 here. It will have a real value there, then 0 will now be on the denominator, and when you have 0 on the denominator, automatically the answer there becomes what? Infinity, or we can say it is what? Undefined. All right, so let's take a look at the other part of it. That is the zero slope. In this sense, the y-axis, the value of the change in y will produce 0, and you are going to have a value there. As you can see here, the value of x can vary, but that of y will remain at a particular point. So that is to say, the value of y will be at a particular point, okay, and the value of x will vary, which can give us a valuable number there. So 0 divided by any number will always produce 0, and that is why we call it a zero gradient or zero slope. Now let's take some examples from some of these various types of gradients that we have explained. All right, so here are some of the examples. Example 1, here we have a graph where to determine the gradient of this particular line. As to do that, the first thing we do is to locate 2 points along this line. All right, so I would advise that you locate the point based on the one that will be easier for you to read. All right, so but any 2 point chosen along this line will always give you the same gradient. All right, so assuming I pick 2 points along this line, let's take this place for example, point, the first point and another point here. All right, so all you need to do is to construct a right angled triangle out of these 2 points along the line. And to do that, we get a right angled triangle out of it. All right, then you connect the right angled triangle. All right, so here we have it. All right, so out of these right angled triangle, the upper part of the triangle, the apex point here, you locate it towards y. This is your y2, is your y2. Then the lower part of the triangle towards y-axis is your y1. All right, so for the bottom part of the triangle formed, then the side where the right angle is formed is the x2. You locate it towards here, that is your x2. Then the point, the lower point of the right angle triangle, as you can see here, that means along this line towards 0, that is your x1. All right, so you can see that all the values are now very much obvious. Here we have y2. Y2 is 8. Y1 is 4. Then x2 is 2. As you can see from here, x2 is 2. Then x1 is the lower part of the triangle, which is 0, the origin. So x1 is 0. So to determine the gradient of this particular line, as you can see from the equation here, this is the formula for calculating the gradient of a straight line. So m, which represents the gradient, y2, that is 8, y1, that is 4, all over x2, that is 2, minus x1, that is 0. So from there, we have it as 8 minus 4 will give us 4, over 2 minus 0 will give us 2. Therefore, the gradient of this particular line is equal to 2. So this is exactly how to determine the gradient of a line. As you can see from this particular question, this is what we call positive gradient. Let's take some other examples. Now, next example, you can see how the line slants. The line slants in this form. Of course, that should be a negative gradient, as we showed in some of the various types of gradient. All right, so to find the gradient of the line, okay, from the graph, we have to locate 2 points, just like we did in the previous one. Let's say I'm choosing a line, the point that line towards 10. Let me also choose the line that corresponds to 4. All right, so assuming this is exactly the 2 points I have chosen, the next thing I am to do is to get a right angle triangle out of this, out of the 2 points chosen. All right, so I now have the right angle triangle formed out of it. So here, what is the value of our y2? Our y2, then y1. Remember, where the right angle is formed takes the position of x2. Then the lower point of your triangle represents your x1. All right, so having taken note of that, the next thing we have to do is to bring out the values. y2 is 10, y1 is 4, because this is y1 towards y here. That is 4. X2 is where the right angle is formed there, and the reason why it will not be taking this position is because the whole thing is slanting down, that's coming down. That is to say, we are reading backward in that sense. All right, so X2 gives us that's minus 3, we can say minus 3 points, but it's not exactly minus 3 as you can see here. So let's say minus 3 point, let's say minus 3.3, within this line. If you are using the normal graph where the calibrations are done, it will be easier for you to read in between the points or the boxes. But as case of this particular one, we are using estimation of the various values that we have here. So x1 rather, we've done x2 already. X1, that is the value here. That will give us minus 1.5, minus 1.5, minus 1.5. So these are the values that we have. Then to find the gradient will now be easier for us. Gradient, as we know, that's the y2, 10, minus y1, which is 4, all over x2, which is minus 3.3, then minus y1, which is minus 1.5, minus 1.5. All right, so having done that, that gives us 10 minus 4 will give us 6, all over. Now let's do the other part of the arithmetic. That is minus 3.3 minus times minus will give us plus 1.5. So how do we go about this? All right, that is minus 3.3, then plus 1.5. That will give us 6 all over negative 1.8. Use your calculator very well. Then the gradient will now be, where we now say 6 divide negative 1.8. Negative 1.8, that will give us negative 3.3 as the gradient. All right, so that's exactly the solution to this particular one. You can see the value of your gradient is negative. All right, so let's take another example. Now let's see how to deal with this kind of example. And if you observe very closely, this is the one we described as the zero gradient, when the line is parallel to x-axis. Now let's locate the gradient of this particular line. All right, so the first thing we do, we locate 2 points along this line. Say for example, I'm choosing this point, a line with 3 here, then choosing another point again, say around minus 2. All right, so having made the choice of these 2 points, and that is x2 here, your x2 is the value that is projected towards x here. These are x2. Then the lower point here, that's our x1. So how do we calculate it going further? What are the values of x? You observe that x align along this line. Both your y, rather I say y align along this line, whereas your x extend in this form. So y2 and y1 align within this particular point here. So that is to say our y2 is 6 and our y1 is equally 6, because it's aligned within this point 6. So the values of x will now be within this extension, that is the x2, x1. x2 value here is 3. X1 value is -2. So how do we now calculate the gradient? Following the formula, y2 is 6, y1 is 6, all over x2 is 3 minus x1 is 2, and that's -2. The gradient will now be 6 minus 6 will give us 0. Then 3 plus 2 will give us 5. Then the slope becomes 0 divided by 5. The answer is 0. And that is why we call this kind of graph zero gradient. Zero gradient. Now let's take the final example. Now in this particular example, here is another nature of gradient that we have here, following the various types of gradient that we've given before now. This is the one we know as the undefined gradient, and this is the line. This is our x-axis here, and this is our y-axis. So this is the line that is being plotted. So to find the gradient of this particular line, which is parallel to y-axis, and we say when the line is parallel to y-axis, what we have is an undefined gradient. Now let's take a choice of 2 points along this line. Let's say 8 here. Let's use these 2 points, 2 here. All right, so making choice of these 2 points, this remains our y2, and this remains our y1. So our x value align within this line, along this line towards x. You can see it here. So our x is one value there. Both our x2 and x1 align here. All right, so we can say that y2 is 8, y1 is 2, x2 is 2. Yes, you can see here, and x1 is still within that point too. All right, so to calculate the gradient of this, then y2 is 8, y1 is 2, all over. Then x2 and x1 remains same value, 2 minus 2. Then that gives us 8 minus 2 will give us 6, all over 0. And you know 0 cannot divide a number, but a number can divide 0. When 0 is dividing a number, the solution to that particular concept is infinity or undefined. So, and that is the result of this particular example. So, do have a great day ahead as we look forward to having finite equation of line from given points. We just got the gradient of a straight line using graph. So the next one, we are going to be finding the gradient using various kind of coordinate points. All right, so do have a lovely day ahead. Thank you for listening. Please don't forget to click on the subscribe button. Thank you for listening.